Hey guys, welcome to section 4.5. We're finally getting away from graphs and we're going into a different application of derivative, which is L'Hopital's rule. Okay? L'Hopital's rule. Real quick before we get into this. What is the limit as x goes to infinity of x over 5? In other words, what's infinity divided by 5? Well, if you go to infinity, even if you divide it by 5, you're still going to get infinity. It's going to grow forever. Okay? Or a really huge number divided by 5 is still a really huge number. But what if I do it the other way? What if I do 5 over x? In other words, 5 over infinity. A massively large number. What's that going to go closer into? 5 over a huge number is actually going to get smaller and smaller until it gets to 0. So infinity on top is infinity, infinity on bottom is 0. That comes up today. Take a look at this problem. Limit as x approaches 2 of x squared minus 4 over x minus 2. So let's plug 2 in. You get 2 squared minus 4 over 2 minus 2, which is 0 over 0. This tells me something. This tells me something is going on. Because this is a hole in the graph, not an asymptote. And holes have limits. So how would you have done this? Beginning of the year, you would have factored it. X minus 2 over x plus 2 over x minus 2. Limit as x goes to 2. And then you would have canceled these two out. And you would say that the limit as x goes to 2 of x plus 2 is equal to 2 plus 2. Is equal to 4. So, if I can factor it, it's pretty easy. And I knew that something was going on because I got 0 over 0. But what if you can't factor it? What if it's a type of problem where it's too difficult to factor? That's when we're going to do L'Hopital's rule. If you get 0 over 0, what we're going to do then is take the derivative of the top and the derivative of the bottom and try it again. Notice this isn't quotient rule. This is just the derivative of the top, just the derivative of the bottom, and try it again. It has to be indeterminate form to be true. If you don't get 0 over 0, then you can't do this. Let's try this. Let's plug in 0 here. If I plug in 0, I get 1 minus cosine of 0 over 0 plus 0 squared. 1 minus cosine of 0 is 1, because I know you know your unit circle. That's 0 over 0. Because it's 0 over 0, I can use L'Hopital's rule. L'Hopital's rule says I can take the derivative of the top and the bottom. Okay? The derivative of the top and the bottom is the limit as x approaches 0. Derivative of negative cosine is sine of x. Derivative of the bottom is 1 plus 2x. Now let's plug in 0. And I get sine of 0 over top of 1 plus 2 times 0. That's 0 over 1, which is 0. So this answer is 0. Notice, I checked it before I did L'Hopital's rule again. If you keep going with L'Hopital's rule, you eventually get 1/2, which is wrong. You only use L'Hopital's rule till you get something that's not 0 over 0. Okay? It's not just 0 over 0. It could also be infinity over infinity and 0 over 0. These others are indeterminate, but I got to turn them into a fraction first. Well, this one's already a fraction, so I don't guess I need that one. There are 7 indeterminate forms. Infinity over infinity, 0 over 0. 0 times infinity, infinity minus infinity, 1 to the infinity, 0 to the 0, infinity to the 0. You have to know those 7 terms. It's going to be on a quiz. I'll just say, what are the 7 indeterminate forms? Let's take a look at this one. I could not do L'Hopital's rule. Why not? Because it's not a fraction. Is there some way I could rewrite this as a fraction? There sure is. That is the limit as x goes to infinity of sine of 1 over x divided by, multiplying by 1 over x is the same as dividing by, multiplying by x is the same as dividing by 1 over x. Now let's check this one. If you plug in infinity, you get sine of 1 over infinity we said was 0. 1 over infinity we said was 0. That's 0 over 0. Because I get 0 over 0, I'm going to use L'Hopital's rule. L'Hopital's rule says if it's a fraction, take the derivative of top and bottom. So the limit, so x goes to infinity. This is a chain rule problem. The outside is sine, so I'm going to do cosine. Times, that's x to the negative 1. Derivative of x to the negative 1 is negative x to the negative 2. On bottom, that's x to the negative 1. The derivative of that is negative x to the negative 2. What do you notice here? Those two will cancel out. So I've got cosine of 1 over infinity. That's cosine of 1 over infinity is 0. Cosine is 0. 1. So I plugged it in the first time to see that it's L'Hopital's rule and got 0 over 0. Did the derivative, canceled out what I could cancel out, plugged in, and now I got an answer of 1. This was a problem that wasn't a fraction to begin with. I had to rewrite it as a fraction. These take some time to get into fractions. They're exponents. What cancels out an exponent? What can I do to cancel out an exponent? I can use a log, because logs cancel out exponents. But if I use a natural log, what do I have to do to cancel out the fact that I used a natural log? I've got to do e. Let's try a problem. X to the 1 over x. Well, that's infinity to the 0 power. So let's rewrite this problem. I want to do e to the limit of the natural log of x to the 1 over x. This is the same thing as this. Why? I put a natural log and an e in there. They cancel each other out, so it's the same thing. For this problem, I'm only going to look at this part right here. So, I know that the limit, as x approaches infinity, what can I do with the exponent? I can put it in front, like that. That's the limit as x goes to infinity. This has to be written as a fraction, but that's really easy to put as a fraction. Is that? If you plug in infinity, you would get infinity over infinity. Infinity over infinity means I need to use L'Hopital's rule. If I use L'Hopital's rule, the derivative of natural log is 1 over x. The derivative of x is 1. So that's 1 over infinity. What is 1 over infinity? 0. However, the answer is not 0. Remember, I got to plug it back in here. So my answer is really e to the 0. And e to the 0 is 1. There's lots of answers that are zeros and ones in this type of problems. Okay? So that's L'Hopital's rule, basically. Remember, it has to be an indeterminate form, has to be a fraction. So if it's not a fraction, rewrite it as a fraction. Lots more practice online for this, guys. If you have any questions, come talk to me.